good people, I'm going to talk about particles and moles. Yes, I've talked about these before, but I thought I might revisit them yet again. When we say particle, what do we mean by it? In a way, the word particle is a stand-in word. It could mean many things depending on the context. Within the field of chemistry, when I talk about particles, I could be talking about the subatomics, namely electrons, protons, and neutrons. However, when I talk about particles, I might be talking about hydrogen atoms, potassium atoms, oxygen atoms. I might also be talking about ions, such as the calcium ion, the fluoride ion, or the ammonium ion. A particle could also be an entire formula unit, such as sodium bromide, aluminium hydroxide, and magnesium chloride. So, ionic compounds can be seen as particle types. The same is true for covalent compounds. And so molecules can also be seen as particles. For example, molecular hydrogen is a particle, carbon dioxide is a particle, and boron trifluoride is a particle. In fact, anything can be a type of particle. And so a pizza slice, a bicycle, a heart rate enhancer, all of these can be seen as particle types. True, when we deal with things on a macro scale, we tend to refer to them as objects rather than particles. Let me have a closer look at this pizza slice. In this particular case, I could say that the pizza slice contains 4 slices of salami and 3 slices of mushroom. I could also express this slightly differently. I could say the particle type pizza slice contains 4 particles of salami and 3 particles of mushroom. What happens if I have 12 slices of pizza? Well, in that case, everything needs to be multiplied by 12. So rather than 4 slices of salami, I would have 48 slices of salami. By the same token, the 3 slices of mushroom would need to be multiplied by 12, and now I would have 36 slices of mushroom. Or to rephrase it using the particle terminology, I could say that the 12 particles of pizza contain 48 particles of salami and 36 particles of mushroom. Is anybody getting hungry? Me too. How does this relate to chemistry? Here I have magnesium chloride. Magnesium chloride is an ionic compound made up of 1 ion of magnesium and 2 ions of chloride. Alternatively, I could say that the magnesium chloride particle contains 1 particle of magnesium ions and 2 particles of chloride ions. If I end up with 100 particles of magnesium chloride, everything needs to be multiplied by 100. And so I will have 100 times 1, which is 100 ions of magnesium, and 100 times 2, which is 200 ions of chloride. We cannot easily measure out 1, 12, or even 100 magnesium chlorides, but a mole of them is something different. Recall that a mole represents Avogadro's number, and so if I have Avogadro's number of magnesium chlorides, I will also have an Avogadro's number of magnesiums and 2 times Avogadro's number of chloride ions. Now, an Avogadro's number of magnesium chlorides is ridiculously large. We cannot actually measure them out one by one. It would take way too long. So when we measure compounds, we tend to do it by mass. So what is the mass of a mole of magnesium chloride? Or what is the mass of 6.22 times 10 to the 23 particles of magnesium chloride? The answer to this question lies in the periodic table of elements. Here is the main group, and next to it I'm going to construct a table. I'm going to look at atomic chlorine, molecular chlorine, and magnesium chloride. In case of atomic chlorine, the formula is Cl. The mass of a single chlorine atom is 35.453 AMU. But if I'm talking about a mole of chlorines, or an Avogadro's number of chlorines, the mass becomes 35.453 grams per mole. Note that when we write out the unit for moles, it gets shortened to MOL. The mass of a single mole of any compound is known as its molar mass. What about molecular chlorine? Well, the formula is Cl2. Its formula mass is twice that of chlorine because I have 2 chlorine atoms, and so it becomes 70.906 AMU. But if I'm talking about a whole mole of molecular chlorine, it is 70.906 grams per mole. Note the difference in the number of actual atoms of chlorine. In case of atomic chlorine, I have an Avogadro's number of atoms of chlorine. In case of molecular chlorine, I have twice as many atoms of chlorine. For atomic chlorine, things are fairly straightforward. A mole of atomic chlorine will give me a mole of chlorine atoms. However, when it comes to molecular chlorine, a mole of molecular chlorine will give me 2 moles of chlorine atoms. Think of that pizza again. You can have 1 slice of pizza, but it will give you 4 slices of salami. What about magnesium chloride? The formula is MgCl2. The formula mass is 95.211 AMU, and the molar mass is 95.211 grams per mole. What about the number of particles present? A single mole of magnesium chloride contains a mole of magnesium atoms, or an Avogadro's number of magnesium atoms. And it also contains 2 moles of chlorine atoms, or 2 times the Avogadro's number of chlorine atoms. And yes, many calculations are heading your way. Think of it as an alternative way to get that heart rate up. That is all for now, and I will see you on the flip side.